3 or 4 years ago, I had a chance to look at it for the first time. And if any of your engineers, and you look at this thing, you say, it is absolutely bizarre. There's no way this thing can work. Because in conventional male-oriented physics, where we put in energy, we got to hit it with something, This makes no sense because it doesn't operate with that philosophy. It operates with the female forces of implosion. So the thing kind of operates backwards. And when you look at it a little bit and you say, well, this thing operates backwards, and then all of a sudden your mind just gets all clouded and confused because you're not used to thinking in those terms. But after a while, it gets kind of simple. And this is brilliant. If Keeley did anything, he was a brilliant machinist and a brilliant mechanic. He just had a cleverness of making things. Water would come in through this orifice. Once he got the thing primed with water in the system, he could just kind of give this thing a little crank, and it would create a vacuum, and the water would draw itself through the machine. Now, one interesting concept is the water formed a part of the mechanism. That's not normal physics. That's not normal engineering. We don't normally do that, where the water is actually part of the motion of the machine. So this thing is kind of like a holistic machine. It's not a machine operating on the water or the water operating on the machine. It's the water and the machine operating together as a whole unit. It's kind of like the human body does. So we give this thing a crank. Water will come into here above this level, this tube, this horizontal tube that goes across the front. The tube goes through this pulsating chamber. I call this a pulsating chamber. And the tubes are hollow. There's nothing inside of them. The same thing with this tube. It's just a straight tube. There are holes in the center so that it has access to the internal volume of this pulsating chamber. This chamber is 1/64 of an inch in thickness. It is red brass. It's very hard, very resonant type brass, whereas this is a yellow brass. It's red brass, kind of like a naval brass. And the interesting thing is, once the water came into this and started through the system, this chamber would begin to pulsate. And because it's mostly got air in it, we would have a pulsation of a high and low pressure forming at intervals, very high frequency. So this becomes a pump. Once the water is in motion, this pulsating chamber becomes a pump with no moving parts. It's really ingenious. Just a year ago, I ran across a NASA paper where these guys, some engineer didn't even have his name on the paper, had designed a waveguide using a transducer, and he had developed a pump using a transducer, there again with no moving parts. So here was a validation from NASA that this concept worked. And I thought that was really good that we ran into that paper. In these two mechanisms, one on each side, these are check valves. The water would come across horizontally and start up through this check valve, and all it is a round ball sitting on a round hole. So water could come this way, but it can't go back down. Then the water would come through these pipes around here, there's two on each side, into these pistons. Now, there's two kinds of pistons. This is kind of an enigma why there's two distinct designs on these pistons. They are not the same. And this left side, your right side, we have what we consider a standard piston arrangement. Underneath, we have a bar that goes underneath that pushes a piston up into this larger chamber. The water would come into the top of that cylinder, on top of that piston. And in the end, there's a valve that goes straight through here. It's a rotary valve, so it just rotates. In this case, it just rocks back and forth. So the water would come through that cylinder. When the valve got in the right place, the water would shoot through into this cylinder, pushing this crankshaft and causing it to rotate. It's real simple. However, the things that go on while it's doing all that is really neat. The pulsations would drive the water past the check valves into this cylinder down here, pushing this rod down, which lifted this weight on the far side here. So it would lift this weight on the far side, thereby putting pressure on this water in this cylinder. So here we've got water under tremendous pressure because the injections of the pulsating waves pounding that water. The minute the little rocker arm rocked the valve back and forth, we've got a high velocity stream of water coming past the valve. So when you close the valve in high velocity water, what do? You get water hammer. You get that pounding. And water hammer is when you close the faucet in your sink and the pipes bang in your basement. That's water hammer. There's infinite pressure in that. So that pressure, I did a computer model of what happens in here. Of course, the computer model is based on ideal conditions, which this isn't. But I was surprised that it showed within 8 cycles of this valve opening and closing, the pressure goes to infinity. Now that's an ideal situation, which this isn't.